Okay, guys, today's lesson's on types of circuits. So the two types of circuits that we are going to learn about are series and parallel. So I've taken the opportunity to draw two types of circuits. The first is on the left-hand side here of the screen is a series circuit, and the second on the right-hand side of the screen is a parallel circuit. Just take a few seconds right now. You can pause the video if you'd like, and try and determine what the difference is between the two types of circuits. Okay, I hope that what you've realized is that in a series circuit, the electrons actually only have one pathway to travel. So remember, electrons always leave the negative terminal and they travel back to the positive terminal of the power source. So in a series circuit, what you have is only one path, one route for the electrons to travel. In a parallel circuit, though, you have more than one. And you can either have two, you could have three, you could have four, you could have 400 pathways. As long as there's more than one pathway for the electrons to travel, it is considered a parallel circuit. So let's look at what would happen here. So the electrons can go down this branch once they leave the negative end, or they could go down this branch. And what will happen is they will meet back up by the time they get back to the positive end, but they have more than one route they can take to get back to the positive end of that battery terminal. So the main difference between a series circuit and a parallel circuit is how many pathways there are. So let's write that down, and you can copy it down on a piece of paper or in your notebook, okay? So series circuit has one pathway. Parallel has more than one pathway. And what does having more than one pathway mean about the way the circuit is going to work? Well, a parallel circuit is much more complex, okay? So it's more complex. It is the way our homes are wired, our apartments, schools, businesses, factories, anything that requires a lot of devices to be running are wired in a parallel circuit. A series circuit is a simple circuit. And the best example I can give is think of a string of Christmas lights. You have one string with a bunch of lights on them. That would be considered a series circuit, okay? Now, there are some differences between the two that go beyond just how many pathways there are. So let's take a look at that. I'm going to draw two more circuits for you. So again, let's put back this. Okay, I'm going to draw, let's say I do a light bulb, a clock. I'm going to erase this negative, and I'll put it, okay. Okay, so that's a light bulb and a clock wired in series, because remember there's only one pathway, and a series circuit really just takes on the form of just a rectangle. And then I'll draw a parallel circuit, and notice how I'm drawing the parallel circuit. I draw my battery on the side instead of at the top or the bottom. That makes it a little bit easier. And here, I don't know, I'll do 3 light bulbs. And so notice how this ends up looking like rectangles too, but now instead of just one rectangle, you have 3 small rectangles. So now I have 3 light bulbs in parallel on the right-hand side, and I have a light bulb and a clock wired in series on the left-hand side. What would happen in a series circuit if one of the devices stopped working? So for example, if this light bulb stopped working, do you think that the clock would be able to run? Well, I hope you answered no, because what ends up happening is the electrons travel around the wires, right? When they get to this broken part, they're going to stop, and they're going to stop and they cannot travel any further. So when you have one portion of the series circuit that's incomplete, or that has a break or has a burnt out device, whatever it may be, it completely stops the other devices that are wired in series from working too. So clock won't work. Okay. What about in a parallel circuit though? What if this light bulb didn't work? So if this light bulb didn't work, well, the electrons are traveling this way, so okay, that light bulb won't work. But that's not the only pathway that the electrons have to travel. So they could come down here. This light bulb will still work. Or they could go down this way, and this light bulb will still work. So the devices still work. And the last thing that you have to remember for the differences between series and parallel circuits is how much power each device will actually receive in the different types of pathways. So bear with me here, guys. I'm going to draw a series circuit here. Just a simple one. I'll draw 3 light bulbs in series. Okay. And I'll do the same thing on the other end. Remember, negative and positive. Okay, so I have a negative and I have a positive end. And again, I'll do this, I'll do this, and I'll do this. Okay. So in a series circuit, what happens is as you add devices in series, so one after another, the more devices you have, the less powerful they become. So more devices means less power. And that's because they are sharing voltage. So the battery has a specific amount of voltage in it, and that voltage is being shared by all the devices in the series circuit. So as you add more light bulbs, each light bulb becomes a little less bright. It becomes dimmer, okay? So if you only had 1 light bulb, it would shine really brightly. If you had 2 light bulbs, the second light bulb will shine just a little bit less, and then so on and so forth. That's very different from a parallel circuit. In a parallel circuit, current or power, voltage stays the same, okay? So it doesn't matter if you have 1 light bulb or if you have 100 light bulbs in the parallel circuit, they will all shine just as brightly, okay? So that's the big differences between series and parallel circuits. Series circuits only have 1 pathway. Parallel circuits have many pathways. If one part of a series circuit stops working, the entire circuit stops working. And as you add devices to each circuit, they will become less powerful. So now let's just spend the last minute or so practicing how you would draw series and parallel circuits. So the first example I want you to do is I want you to draw circuit with a 1-cell battery, a switch, and 3 lamps connected in series. Okay, so you can now pause this video and practice this drawing and then press play to see if you've done it correctly. So I'm going to change the color of my pen now, and I'm going to draw so I know it's a series circuit because I know that the 3 lamps have to be connected in series, so it's going to just take on the form of a rectangle. I'm going to draw my 1-cell battery first, so small line, long line, negative end, positive end. It needs a switch, and remember the switch should always be right after the battery and right before your device. It doesn't specify whether or not it needs to be open or closed, so I'm just going to draw an open one. Okay, and then I have to draw 3 lamps in series, so one after another. So 1, 2, and then I'll draw my 3rd one over here, 3. Okay, remember when you're drawing these at home, you're using a ruler, so it's looking a lot neater than mine is. But here we have our power source, we have our switch, and we have our 3 light bulbs in series. There's 1 path, Is this an open or a closed circuit? It is open because the switch is open. Will the lights work? Lights won't work, all right? And the lights won't work because the switch is open, which gives the electrons a route to escape from, okay? So I hope everyone got this one correct. Now let's move on to the next one. The next example I want you to try out is draw a 2-cell battery with 3 lamps in parallel with a switch for each lamp. Okay. So again, pause this video and try it out on your own, then press play to see if you got it right. So this needs to be a parallel circuit because the 3 lamps need to be connected in parallel. When I'm drawing parallel circuits, I'm always putting my battery on the side. So again, it's a 2-cell battery, so small, long. One end's negative, one end's positive. Now I'm going to draw my lamps in parallel. So 1. Remember, they each have to be on a separate branch. 3. I will connect this way, and I'll put a circle around each of them. Okay, and then the last part says it needs a switch for each lamp. Because it's for each lamp, I need 3 switches. And in this case, I'm going to use closed switches. So 1 switch for this lamp, 1 switch for this lamp, and 1 switch for this lamp. Okay, so this is parallel. It's closed. And will the lights work? The lights will work. And how many pathways does this parallel circuit have? So we can show it. There's 1 path, 2 paths, 3 paths. So this is 3 pathways. Okay, now you can start getting started with the practice that I've put up on the Google Classroom.